Welcome to Dilations. So a dilation is a type of translation. So in the past we've looked at moving a graph along the x-axis, moving it up and down the y-axis. So we're going to look at now stretching the curve horizontally or vertically. Good example would be a circle being distorted into an ellipse. So for a vertical translation, so that means up or down, we replace y with y over a, and for a horizontal dilation, so that means stretching it left and right, we replace x with x on a. So for y equals x squared minus 1, we are going to look at three different types of dilations, and we're going to create the new equation and the graph that goes with it. So let's start with vertically by 2. So a reminder that vertically by 2 means replacing y with y over 2. So where the y is in the equation, I replace it with y over 2. I make y the subject, so I just double the other side and I get 2x squared minus 2. So the 2 in front of the x squared means that it's a steeper parabola, and minus 2 from our past is to translate it down to units. And that is our graph. Horizontally by a third means that we replace x with x over a third. And if we divide by a third, that's the same as 3 lots of x. So where the x is, we're going to put 3x. So it's x squared, so in place of x we put 3x, so we get 3x all squared. So we get 9x squared minus the 1 on the end. So once again, it's a steeper parabola, even steeper than the last one, and it's translated down 1. And here is our graph. So you can see that the graph actually becomes a lot steeper. I've actually changed the scale so that I could fit it on. Y equals x squared minus 1. So we're going to do vertically by minus a half. That means we replace y with y over minus a half, or replace y with minus 2y. So where the y is, put minus 2y. Divide both sides by minus 2. So we get minus a half x squared plus a half. We know that a minus in front of an x squared means that it becomes concave down. The half makes it wider than the normal parabola, and it's translated up a half. So that is our graph. So now we're going to have a look at something that's a little bit more trickier than what we've just looked at. So we've got y equals x minus 2 and x plus 1. We're going to sketch the curve if a horizontal dilation of minus 2 is applied. So horizontally means we're affecting the x. So for our y equals x minus 1, x plus 2, we're going to replace x with minus x minus 2. So wherever there is an x, I put minus x over 2. Now we're going to also have it in the form of its quadratic, just so that we can use the two different ones to find our x-intercepts and y-intercepts. So expanding that, we get a quarter x squared minus a half x minus 2. So x-intercepts are when y equals 0. So if I let y equals 0, I'm going to use the factorised form, so the original one. And we solve each bracket. So minus x over 2 minus 1. Let's just focus on that. So I'd add the x on 2 across to the 0 side. So I get x on 2 equals minus 1. Double it, so I get minus 2. And minus x on 2 plus 2, I'd add the x on 2 across, and then I'd double the 2 to get 4. The y-intercept, well, I'm going to use the other equation. That's why it's a lot easier. I let x equals 0 in and get y equals minus 2. And there's the graph of the original, which is the red one, and the graph of the new one, which is wider, because we've horizontal dilation of minus 2. So you can see that we actually have the new one where the blue is. Thank you.